Hello all, welcome back to my channel. As you all know, my name is Disha, pursuing BE in Electronics and Communication at Sri Venkateshwara College of Engineering. Today I am here to give a presentation on my internship topic entitled as PCB Designs for Ozone Leak Monitor under the guidance of Professor Ramya P. in the Department of Electronics and Communication Engineering and external guide as Mr. Vardhan Kumar. Contents to be discussed are company profile, plan of work, introduction, objectives, block diagram, flow algorithm, components required, advantages and disadvantages, applications, results and discussions, conclusion, references. I worked as an intern in the company called Southern Electronics for a month and shortly called as Sionix. It has four departments in it. Firstly, it is fire suppression system, avionics, and life science. Let's go deep into the topic. Firstly, fire protection system. In fire protection system, they have crafted a aircraft fire protection, that is LCA fire warning system, and they have also configured pre-configured and ready to install fire suppression solutions for suitable for high risk areas such as electrical cabinets, mechanical and chemical combustion zones. In avionics systems, avionics LRUs, defense electronics, base servicing equipment, aircraft harness, electroacoustic products, aircraft switches. These are the products produced by the Southern Electronics or Sionix. In avionic LRU, it had it had designed a fire detection warning systems for LCA and standby centralization warning panel, NVG navigation compatible for choppers, and intercom system for choppers again, intercom systems for Jaguar aircraft, and missile control panel for Jaguar aircraft, fatigue meter for Jaguar, and like stall warning tone generator. These are the products which have been invented in the avionic LRUs. In defense electronic, it had contributed much. Mainly focused on air treatment, water treatment, and other applications. In air treatment, it mainly focused on ozone supplies enriched oxygen, which in turn helps maintain the natural flow of clean air. And in water treatment, due to its excellent disinfection and oxidation qualities, ozone is widely used for purifying drinking water. Unlike chlorine, ozone leaves no harmful chlorinated byproducts in the water, and other applications are ozonators are used in a wide variety of applications, starting from aquaculture, storage, poultry, etc. Main objectives of this internship is to automate various stages of production process such as designing and development, PCB board designing and soldering the boards, to track and monitor the quality of products throughout the production process, to track inventory levels of raw materials, finished products and spare parts. The project I have completed in internship period is PCB design for ozone leak monitor. Ozone is an inorganic molecule with the chemical formula of O3. It is a pale blue gas with a distinctively pungent smell. Ozone is produced in the two ways. One is natural and one is artificial. Naturally, it is produced by UV rays and by lightning, also by corona discharge. And artificially, it is formed by the passage of oxygen into the electronic plates. It forms an corona discharge, and the ozone is formed, and byproduct of ozone production is oxygen. So in this video we can observe the uh, formation of ozone molecule by the UV rays method. Like when UV rays is passed to NO2 bond, it breaks down into NO and oxygen. The left out oxygen molecule is combined with the O2 and forms the ozone molecule. In this slide, we would discuss about the block diagram of ozone leak monitor. Firstly, ozone leak monitor is a device designed to detect and measure the leakage of ozone gas, typically used in industrial settings where ozone is utilized, such as water treatment plants, semiconductor manufacturing companies, and medical facilities. It works by continuously sampling the air for ozone concentration levels. And coming to the block diagram of ozone leak monitor. Firstly, input is 230 volts of AC alternating current of 50 hertz of frequency. Step down transformer, 230 volts to 13 volts. This transformer reduces the voltage from 230 volts to 13 volts for safe operation of the electronic components. And the second component is rectifier and filter. The AC voltage is converted into DC through a rectifier circuit and then filtered to smoothen the voltage. Sensor. This is the ozone sensor that continuously samples the air and samples the air for ozone concentration levels in the form of ppm, that is parts per million. And second, like next component is comparator. Comparators, there are two comparators in this system, namely comparator 1 threshold value is 0.05 parts per million, compares the ozone concentration level with a set threshold of 0.05 ppm or parts per million. If the ozone level exceeds this threshold, it triggers the LED 1 and the buzzer to alert the person or a guide. And the second comparator, that is comparator 2, threshold is 0.1 ppm, compares the ozone concentration level with a higher threshold of 0.1 ppm. If the ozone level exceeds this threshold, it triggers LED2 and relay. LEDs and buzzer. LED indicates and a buzzer provide visual and audible alerts when ozone concentration exceeds the set thresholds. Relay is used when the ozone levels surpass the higher threshold. The relay is triggered. Relays are electrically operated switches used to control the high power devices or signals with the low power signals. Ozonator. This is the device responsible for generating ozone. It could be an external component or part of the system for completion of these purposes. Overall block diagram outlines block diagram outlines the key components and their functionalities in detecting and responding to ozone leaks in an industrial settings. The flow diagram of the ozone leak monitor goes like this. Initialization of the system. Data acquisition. Data acquisition means like collecting the ozone concentration in the air or the atmosphere. And data processing. Data processing is nothing but sampling of the ozone concentration in air in the measurements of 0.05 ppm to 0.1 ppm. And there is a condition: if ozone level is more than threshold, it moves to the trigger, trigger alarm is going to take place. And if it is less than the threshold, the system is continuously monitoring. And after triggering the alarm, like any person have to notify this and then stop the leakage of ozone, initiate response action. Like there are two comparators. When the ozone leakage of 0.05, it just gives the trigger alarm and LED. And when the comparator 2 is enabled, a relay is enabled and it controls the response from the comparator and isolate the infected area. Technical specification. Operating voltage, it should be around 330 volts in AC, and it may be plus or minus of 10%, like 23 volts at 50 hertz, and power consumption is 10 watts approximately. Level 1 threshold is 0.05 parts per million. Level 1 output is buzzer and threshold 1 LED. Level 2 threshold is 0.1 ppm or parts per million. Level 2 output is buzzer and threshold 2 LED, and it also activates the relay. And PFC rating is 240 volts, and it is in the form of AC alternating current 7 amps. Enclosure is polycarbonate. Components required for ozone leak monitor is AC input 230 volts of 50 Hz. The device starts with an input of 230 volts AC supply, power supply of 50 Hz, and second component is a step down transformer to 30 volts or 13 volt. This transformer reduces the voltage from 230 volts to 13 volts for the safe operation of the electronic components. Third component is rectifier and filter. The AC voltage is converted into DC through a rectifier circuit and then filtered to smoothen the voltage. Fourth component is comparator. There are two comparators used in this project. That is comparator 1, which performs at the threshold of 0.05 ppm, and comparator 2, which works on the threshold value of 0.1 ppm. And next it is sensor. We are directly using the ozone sensor, which continuously samples the air for ozone concentration level. LED and buzzers are used when the triggering of the comparator is when the comparators are triggered, and relay is used to control the like electronic device or the signals in the electronic device. Ozonator, it can be used inside the system or external part of the system, which like produces or forms the ozone gases. Ozone sensor. As we see in this picture, this is the ozone sensor. Model number is MQ131. Type is semiconductor. It only senses the ozone gas, and sensing ranges from 10 to 1000 parts per billion. But we require only from 0.05 ppm to 0.1 ppm. Operating voltage is 5 volt DC or AC. Heater resistance is 34 ohms to like plus or minus of 3 ohms of the room temperature. And standard test conditions are: it can withstand with the temperature of 20 degrees Celsius plus or minus 12 degrees Celsius, and humidity of 55% plus or minus 5% of room humidity. And coil voltage is 5 volts plus or minus of 0.1 volt. Heater voltage is 5 volts plus or minus 0.1 volt. This is the complete circuit diagram of the ozone sensor. This is the ozone sensor which has 6 pins. Pin 2 is connected to the VH or AC voltage. It's the input, and pin 1 and 3 is connected to the regulator. Here it is. And pin 6 and 4 is connected to the VC, that is DC voltage, like rectifier and filter. Voltage flow selection. In this voltage flow selection, it is an amplifier, but in this I am using it as the buffer. Like whatever I give as an input voltage, I should get the same voltage in the output side. So it acts as a buffer. It doesn't amplify or attenuate the signal. Advantages and disadvantages of the ozone leak monitor. In first advantage, improved efficiency, enhanced quality control, optimal resource utilization, improved safety. In disadvantage, cost, limited customization, security concern. Cost, as we are using relays and buzzers, this may cost. Like the components used are costly one, and these are effective ones. And limited customization, like like hospital requires the other threshold values, and industrial areas require other threshold voltage or values or ozone concentration. Depending on their customization, it should be provided. So these are the limited customization and security concern. Application, design and engineering, embedded system, customized solution, rapid prototyping. These are the applications of my internship. Designing and engineering, as I worked like 10 days for and design and development department. I've learned how to design and how to test case and how to give a best result. Embedded system, as we are working on many microcontrollers on PCB boards. I got some knowledge about embedded system and customized solutions, like based on client's requirement and real-time problems. We used to make a solution or customized solution. Rapid prototyping, like we have in the company there is a time limit. If one project has to be done according to the client, these are the terms and conditions which has to be take care of, and which has to be completed within the time given. This is the complete ozone leak monitor on a PCB board. We can see here there are relays and buzzers. These are the complete circuit or the PCB thing of ozone leak monitor. Here the concentration of ozone which has been leaked, it would like it was display like display was here, and this is LED 1 and LED 2. When the threshold of 0.05 is triggered, this LED will be on, and when the threshold of 0.1 ppm is triggered, this LED was on, and relay used to control the whole system or the electronic components. Results of this internship is I've learned how to work in a team and how to lead the team. Secondly, it is a presentation skills. I've learned how to present in a proper way and ethical way. Real-time problems. I have faced many real-time problem situations coming from the clients, and we used to work on that. This had helped me in the research and development department. And technical skills is like learning the Proteus simulation. which is very important before the PCB designs. These are the references I have considered for my project. Thank you for watching the video, guys. Please do view and like the video. If you didn't subscribe my channel, please do subscribe it now for more interesting updates on electronics and communication engineering topics.